Hello everyone. So we welcome you all to Mock Test for You channel and powered by Minerva. So myself Mullah Sohail and I will be continuing my class of inverse trigonometric functions. So last two sessions we have completed the entire chapter and we will be discussing some problems regarding this chapter. So first problem of the day is find the value of x if tan inverse x minus 1 divided by x minus 2 plus tan inverse x plus 1 divided by x plus 2 is equal to pi by 4. So basically we need to find the value of x in here. So first thing, they have given this equation, and looking at this equation, the property of inverse trigonometric function that comes in my mind is tan inverse x plus tan inverse y. So by this property we can say that this one is equal to tan inverse x plus y divided by 1 minus xy. So I will be using this one in here, and let us write that expression in this way. So what we have is, the solution goes like, so tan inverse big bracket divided by x plus y, so here x is this one, x minus 1 divided by x minus 2 plus x plus 1 divided by x plus 2, then 1 minus x into y. So x minus 1 divided by x minus 2 into x plus 1 divided by x plus 2. And that is equal to nothing but pi by 4. Now what we can do is, we can take this tan inverse that side and it becomes tan pi by 4. And we are well aware the value of tan pi by 4, that is 1. Tan 45 is 1. So here let us do the LCM of these two in the numerator and denominator. After doing it, what we have is, the LCM of these two is x minus 2 into x plus 2. And we know that x minus 2 into x plus 2 is nothing but x square minus 2 square. So x square minus 2 square we have, and here we have x minus 1 into x plus 2 plus x plus 1 into x minus 2 divided by what we have in here, the same LCM. It will get multiplied here, x square minus 2 square, then minus of, look at here, x minus 1, x plus 1, a minus b into a plus b, that gives us our x square minus 1 square divided by x square minus 2 square. So now you see that these two gets cancelled, is equal to 1. Don't forget to write that one. This is equal to 1. So what we have in here, the next step what I'm going to do is, so let us multiply this one. So what do you have if I multiply? You get x square, then you have minus x plus 2x. So we have plus x, then we have minus 2. And in this side we have x square plus x square, 1 and 1x and minus 2x. So we have minus x, minus 2 divided by, we have this one, x square minus 4. Then we have minus x square plus 1 is equal to 1. So let us see what we get. Now this minus x and plus x will get cancelled. So minus 2 minus 2. So we have, if I take 2 common, we have x square, and this minus x square and x square will go away. So we have in here x square minus 2 is equal to 1. This one divided by minus 4 plus 1, that is minus 3. This is what we have. So what I will do is, I will take this minus 3 by 2 that side. So what happens in here after taking it that side is, so what we have is x square minus 2 is equal to minus 3 by 2. This is what we get. Now take this to that side. So x square is equal to 2 minus 3 by 2, and that gives our half, right? So x value is nothing but x is equal to plus minus square root of 1 by 2. That's my answer. So that's how we solve this problem. It's all about the properties. This chapter is all about the properties. Using the properties, we have to solve each and every question. Now we move on to the next question of the day. What we have is here, we again go on to the same type of question, that is prove. So we have to prove this expression is equal to 0. So when we look at this question, it looks so many complicated. There are so many complicated things inside tan, right? Tan inverse. So first thing, when we see tan 2a, the thing that clicks in my head is that the formula of tan 2x. The formula of tan 2x which we have learned in class 11, that was given by 2 tan x divided by 1 minus tan square x. So this was the formula which we have learned in class 11. So I will be using that formula in here and I will write here LHS. So this one will become tan inverse half of 2 tan A divided by 1 minus tan square A. Now after writing this, what I see in here is, here we have tan inverse cot A and here we have tan inverse cot cube A. So there is nothing to be done. So when I see tan inverse something plus tan inverse something, we can use that property of tan inverse x plus tan inverse y, which we have done in previous question. So I will, using that property, what we have is plus tan inverse cot A plus cot cube A divided by 1 minus cot A into cot cube A. That gives our cot to the power 4A. So this is what we have. Now what I will do is, so this one, this 2 gets cancelled. So what we can write this one as tan inverse tan A. Don't be worried, just do step by step, you will get to the right answer. Now, if I look at this one, what I do, I take cot A common from the numerator. Now, if I take cot A common from the numerator, what we have in here is 1 plus cot square A. Now, if you look at the denominator carefully now, you see it's in the form of a square minus b square, where a is 1 and b is our cot square A. Okay, so if I express this one in that form, a square minus b square, so the formula which it will give us, it is 1 minus cot square A into 1 plus cot square A. So once we see that thing, what we can do? We can cut these two. So what we have is, we have tan inverse tan A divided by 1 minus tan square A plus tan inverse cot A divided by 1 minus cot square A. So after looking at this, what I will do is, now I will use the formula of that property of tan inverse x plus tan inverse y again. So after using that, what we get is tan inverse x plus y. So we have tan A divided by 1 minus tan square A plus cot A divided by 1 minus cot square A divided by 1 minus tan A divided by 1 minus tan square A. Then we have multiplied by cot A divided by 1 minus cot square A. Now, after writing this, now if I look at carefully, if I look, let us take this one in the rough. Cot A divided by 1 minus cot square A. So cot A divided by 1 minus cot square A. Now, if I transform the cot into tan, what happens this one? So this becomes 1 by tan A divided by this becomes what? 1 by tan square A. So now if I take the LCM, what we have is, we have tan A up and divided by tan A minus 1. This is what we have. Now if I take minus common, it will be same as this one. So we made a mistake, it will be tan square A, because tan square A minus 1. So what we have, if I take minus common, we have tan A divided by 1 minus tan square A. So what we can say that this cot A by 1 minus cot square A is nothing but it's negative of this thing. So if it's negative, so this plus this gives us 0. So the entire thing is 0. So what we have is tan inverse 0, and that is nothing but 0. That's my answer. Okay, by solving this, we see that cot A by 1 minus cot square A is nothing but it is minus of tan A by 1 minus tan square A. So looking at that one, so we can say that the addition of these two will give us 0. So we don't have to solve the denominator, and that's it, we get the answer as 0. So that is our question number 2. So we have another proof of the day, that is sine inverse this plus cos inverse that is equal to tan inverse this one. So whenever you see problems of mathematics, so it's all about the approach, which approach you're doing. So it's all about taking the first step. So if I look at the question, so basically the thing which flashes back to us is that we have never came across the property of sine inverse plus cos inverse, but we came across the property of tan inverse x plus tan inverse y. So once we see that thing, and even the answer in the right hand side, what we have to get is tan inverse. So the first thing that clicks in my head is that I need to transform this sine inverse into tan inverse and cos inverse into tan inverse. Then we can get to the answer in my right hand side. So we have to start with the left hand side. So when I start with the left hand side, so first I will take this sine inverse x by root over 1 plus x square. So what I will do is I will write let sine inverse x divided by root over of 1 plus x square is equal to t, or is equal to y, whatever you want to write. So we need to, so my operation is what? I need to change the sine inverse into tan inverse. So what I will do, I will write x divided by root over of 1 plus x square is equal to sine t. And we are very well aware that tan is nothing but sine by cos. So we know sine, so let us get cos. So sine t is this one. So cos t is equal to what? We know one thing, that cos t is 1 minus sine square t. So that is nothing but is equal to root over of 1 minus square of this thing is what? X square divided by square root. This one will go away. So we have 1 plus x square. Now if I do the LCM, what we have in here is 1 plus x square minus x square divided by 1 plus x square. So this x square goes. So what we have is root over of 1 by 1 plus x square. So my cos t is given by 1 by root over of 1 plus x square. So my main motive was to find tan t. So tan t is equal to what? So the tan t we have got, that is equal to sine t by cos t. And that is nothing but x by root over 1 plus x square divided by 1 by root over 1 plus x square. So this one goes away. So we have x. Now if tan t is equal to x, so t is equal to what? So t is equal to tan inverse x. So in place of sine inverse x by root over 1 plus x square, so I can write tan inverse x. So now we know this one, the first one, that is nothing but tan inverse x. Now we have to look into the second one, that is cos inverse x plus 1 divided by root over of x square plus 2x plus 2. So the same way we have to transform that into tan inverse. So let us do that thing. So again we'll start with the assumption that cos inverse that thing is equal to, let us take that one as y. So my assumption will be, let cos inverse x plus 1 divided by root over of x square plus 2x plus 2 is equal to y. Now once we have cos, so we need to get sine. So how to get sine? Achha, this cos inverse will go that side. So what do we have? X plus 1 divided by root over of x square plus 2x plus 2 is equal to cos y. After doing this thing, we know we need to get sine, right? So why do we need to get sine? Because tan is what? Sine by cos. So what we have in here is, so sine y is nothing but square root of 1 minus cos square y. So that is equal to root over of 1 minus, now cos square y is what? Square of this thing. So what we have is x plus 1 whole square divided by square of this thing. So square root will go away. So what do we have? X square plus 2x plus 2. So this is what we have. Now if I do the LCM, what we get is square root x square plus 2x plus 2 minus, let us do this a plus b whole square. So it will be x square plus 2x plus 1 divided by x square plus 2x plus 2. So if you look at carefully, so minus x square will get cancelled, minus 2x and 2x will get cancelled. So we are left with 2 minus 1, and that is 1. So 1 in the numerator divided by root over of x square plus 2x plus 2. So my sine y we got is this one, and cos y we already had was x1 divided by x square plus 2x plus 2. So now we are left with finding tan y. So tan y is equal to sine y divided by cos y, and that is nothing but 1 by root over of x square plus 2x plus 2 divided by x plus 1 divided by root over of x square plus 2x plus 2. So this 2 gets cancelled. We have 1 by x plus 1. This is what we have. So my tan y is this one. So therefore y is nothing but tan inverse 1 by x plus 1. So this is what we got. So this also we have found out, that is tan inverse 1 by x plus 1. Now after finding these two, now we will apply that property tan inverse x plus tan inverse y, and we will see what we get. Now if I see tan inverse x plus tan inverse y, that is tan inverse x plus 1. Now if I use that property, what happens is that tan inverse x plus 1 by x plus 1 divided by 1 minus x into this one. So we get this thing. Now let us do the LCM. What we have is tan inverse, numerator we have x into x plus 1 divided by x plus 1, and denominator we have x plus 1 minus x divided by x plus 1. So this x plus 1 will get cancelled. This x minus x and x will get cancelled. So what do we have is x square plus x plus 1. So we have is tan inverse x square plus x plus 1. So that's my answer. I know it's a bit lengthy, but it's the way we have to do. We have to solve the question like this. There is no other way. Now most of you will say nothing. So that's how we solve this question. So now here we have some different type of questions. So we need to find the value of cos inverse cos of 13 pi by 6 and tan inverse tan of 7 pi by 6. Now I told you that whenever we have cos inverse and cos like this, we can remove them. Whenever we have tan inverse tan, we can remove them. But we can only remove them. There is a criteria, there is a condition. The condition is that whatever is inside in here, cos, it has to be within the principal value branch of this inverse function. So if I see 13 pi by 6, what was that principal value branch of cos inverse function? The principal value branch was principal value branch is equal to, of course, was what? It was 0 to pi. But if I look at carefully, 13 pi by 6, it's way more than pi. So what we can say that this 13 pi by 6, we cannot remove this cos inverse and cos because 13 pi by 6 does not lie in the principal value branch. So what I have to do is, I need to simplify this one. So I have to write this one as cos inverse cos of. Now you see here, listen very carefully, that 13 pi by 6. Now I will check what are the multiples of, what are the closest multiples of 6 are in 13. So the closest multiple we can think of 6 is 12, that is closest to 13. So I can write this one as 12 pi plus pi divided by 6. The closest multiple of 6 to the 13 pi is 12 pi. So after writing this, what I will do is, I write cos inverse cos of, this becomes what if I separate them. So we have 2 pi plus pi by 6. Now we have learned one thing in trigonometric functions in class 11, that whenever we see complete angles like this, it means what? The trigonometric functions repeats its value after every complete cycle. So we can remove this 2 pi. So it is basically nothing but cos inverse cos of pi by 6. And once we see this thing, now you look at here, pi by 6 is 30 degree and it lies within this principal value branch. So we have cos inverse cos will go away. Now we can write pi by 6. So that's my answer. Now again we see here, so I have tan inverse out. tan inside. So tan inverse and tan will go away? No. Why it won't go away? Because 7 pi by 6, that is greater than 180 degree. But the principal value branch of this tan inverse is what? Principal value branch is nothing but, it is minus pi by 2, 2 pi by 2. This is the principal value branch. And if it's going beyond pi, how can it exist within the principal value branch? Since it cannot exist in the principal value branch, we cannot remove tan inverse and tan. So we have to simplify. So what do I need to do? Again, what is the closest multiple of 6 to 7 pi? So we can write this one as tan of 6 pi plus pi by 6. This is what we can write. So what we have is tan inverse tan of, now we have what? Pi plus pi by 6. So we get tan inverse. Now we need to see that tan of pi plus pi by 6 is how much? Now pi plus pi by 6 lies in second quadrant, and in second quadrant tan is negative. So I will get what? Minus tan of pi by 6. Now when we have tan inverse minus x, we have learned one property, that tan inverse minus x is nothing but minus tan inverse x. So this minus will come out. So we have minus tan inverse tan pi by 6. So this tan and tan inverse goes away. So we have minus pi by 6 as the answer. So now we have this question. So prove that sine inverse 8 by 17 plus sine inverse 3 by 5 is equal to tan inverse 77 by 36. Now in here again you see that here we haven't learned a formula of sine inverse plus sine inverse. So what I will do is I will transform them into tan inverse, and then we'll equate, then we'll check whether this one is coming or not, with the matching with the right hand side or not. So let us start with the left hand side. So we have sine inverse 8 by 17. So I will take that one as x. So after taking that, so what we have is sine x is equal to 18 by 17. So we need to find cos x. So cos x is nothing but root over of 1 minus 8 by 17 whole square, 1 minus sine square x. So what we have is root over of 17 square is nothing but 289. So 289 minus 8 square is 64 divided by 289. So what we have cos x as, this is coming out to be 64, that is 225. 225 divided by 17, and square root of 225 we know that is 15. So 15 by 17 we are getting cos x. So if sin x is this, cos x is equal to that. So tan x is equal to what? It's very easy. So tan x is nothing but, it will be 8 by 17 divided by 15 by 17, and that is nothing but 8 by 15. So we got this one, that is 8 by 15. Now what about this sine inverse 3 by 15? What we are going to do that one? The same way we'll do sine inverse 3 by 5 is equal to y. So we get 3 by 5, or we can say sine y is equal to 3 by 5. So from here let us find cos y. So cos y is equal to square root of 1 minus 3 by 5 whole square, and that is equal to square root of 1 minus 9 by 25. So what you are getting is, if I take LCM, we are getting 16 minus 9, 25 minus 9, that is 16, square root of 16 by 25, and that gives us our 4 by 5. So tan y is nothing but sin y by cos y, so that is 3 by 4. So the tan y we are getting is 3 by 4. So from here, y is equal to tan inverse 3 by 4, and from here x is equal to, we haven't found out this one, it is tan inverse 8 by 15. Now the answer is 77 by 6. So now we have this one we know, now this one we know. Now after knowing this one, we will use the property of tan inverse x plus tan inverse y. So let us do that. The reason I'm doing it here because I want to teach you a shortcut. So let me just do this in here. So tan inverse 8 by 15 plus tan inverse, we have 3 by 4. So what we have in here is tan inverse 8 by 15 plus 3 by 4 is equal to 1 minus 8 by 15 into 3 by 4. So let's not cut anything because we know already that. So now if I take LCM in here, so we get 60. So this one we have 32 plus 45 divided by, we are getting in here as 60 minus 24 divided by 60. So this goes out. So we have tan inverse 77 up and 36 down. So that's what the answer is all about. Now, I was talking about a shortcut. Now the shortcut is this one. Now look at here carefully. The question is sine inverse 8 by 17, right? So in order to transform it to tan inverse, what I will do is, listen very carefully. So we have sine inverse 8 by 17. The shortcut is, sine is what? Perpendicular by hypotenuse. So we have, what I will do is, I will write 8 as perpendicular and 17 as hypotenuse. And tan is what? Tan is nothing but perpendicular by base. So I keep that perpendicular as 8 because perpendicular is equal to 8. And the base is what? It's square root of hypotenuse square minus perpendicular square. So square root of 17 square minus 8 square. And that is equal to tan inverse. You're getting 8 divided by, we already found out that 17 square minus 8 square is 15. So we are getting 8 by 15. You see, it's a shortcut. So we are doing so many things, but in 2 steps we can easily transform sine inverse into tan inverse. In the same way, sine inverse 3 by 5 will be what? So sine inverse 3 by 5 will be, sine inverse 3 by 5 will be tan inverse, it's 3. So it will be 3 divided by square root of 5 square minus 3 square. So that is equal to tan inverse 3 by 4. Again, 2 steps we can transform sine inverse into tan inverse. So you by this shortcut way you can transform any trigonometric function into other trigonometric function. Unfortunately, you cannot do this transformation in your board exams. Why? Because these are shortcuts which we cannot do. We have to do it like this. So these shortcuts are mainly for your competitive exams, or if you want to check your answers whether you're getting correct answers or not, for that purpose. So you cannot use this one and solve the question. So this is how we do it. So now here we have our next question, that is cot inverse of this bigger thing is equal to x by 2. So we have to prove this one. Now when you look at this thing, it's like confusion. Now what I will do. Now here it's a bit easy if you remember some formulas of class 11. So how can I simplify the left hand side? Now look at the left hand side very carefully, and what I see in here is, inside the square root it is 1 plus sine x. So that one, what I will do is, I will write that one as root over of cos square, look, sine x. Sine x, I can write it as 2 sine x by 2 and cos x by 2. So when I'm going to write this one as 2 sine x by 2 and cos x by 2, I can write it as cos square x by 2 plus sine square x by 2 plus 2 cos x by 2 sine x by 2. So once I can write 1 plus sine x as this way, so very commonly something comes in your head is a square plus b square plus 2ab. So once you see this thing, so we can apply that formula of cos x by 2 plus sine x by 2 whole square. In the same way, if I do in here, what I will get is, here it's minus 2ab. So I will get this one. I will write here directly. So this one will be cos x by 2 minus sine x by 2 whole square. Then we have divided by, this one becomes what? Root over of cos x by 2 plus sin x by 2 whole square. Then we have in here minus of root over of cos x by 2 minus sin x by 2 whole square. So once you see that square root and that square, so we can remove them. And if I remove them, so what we have at the end is cot inverse. The numerator becomes what? This, if I think of it as cos x by 2 and sin x by 2. So cos x by 2 plus sin x by 2. Then we have that side as cos x by 2 minus sin x by 2. Then in the denominator what we have is cos x by 2 plus sin x by 2. Then what we have is minus cos x by 2 minus sin x by 2. Now when I am having minus, so what I will have? Minus of cos x by 2. Then minus minus becomes plus sin x by 2. So by simplification we get up till here. Now when I see this one, now we can cut. So this one and this one we can cut. Then this one and this one we can cut. So what we have is 2 cos x by 2 divided by 2 sin x by 2. So the 2 and 2 will get cut. So basically what we have is cot of cos x by 2 divided by cot inverse divided by sin x by 2. So this cos x by 2 and sin x by 2 is nothing but cot x by 2. So cot inverse cot x by 2. So what we have, cot inverse and cot will go away because 0 to pi by 4, it is within the principal value branch of cot. So we have, I hope everybody knows what is principal value of the value branch of the cot, that is 0 to pi. So what we have in here, x by 2. And that is how we prove this question. So we have here another proof of this chapter, that is 9 pi by 8 minus of this thing is equal to 9 pi by 4 sin inverse 2 root 2 by 3. So when I see this proof, so if I look at the left hand side and look at the right hand side, there is one 9 by 4 term. So if I look at these two terms, I can take 9 by 4 common. So if I take 9 by 4 common, what we have in here? We have pi by 2 in here. We have pi by 2 in here. And we have minus, it becomes sin inverse 1 by 3. This is what we have. Now, we know one formula, the property, that is cos inverse x plus sin inverse x is equal to pi by 2. So cos inverse x is equal to what? Pi by 2 minus sin inverse x. So if I have here pi by 2 minus sin inverse 1 by 3, so what I can write? This one I can write it as cos inverse 1 by 3. But I need my answer in sin inverse term. So what I have to do? I have to transform this cos inverse into sin inverse. So how will I do? So we will write let cos inverse 1 by 3 is equal to y. So cos y is equal to 1 by 3. So from here we need to find sin y. So sin y is nothing but root over of 1 minus 1 by 3 whole square. And that is root over of 1 minus 1 by 9. So we are getting square root of 8 by 9. So square root of 8 is nothing but 2 root 2. So we are getting 2 root 2 by 3. So sin y is equal to 2 root 2 by 3. So therefore y is equal to sin inverse 2 root 2 by 3. So here we can write the answer that 9 by 4 cos inverse 1 by 3 is equal to 9 by 4 sin inverse 2 root 2 by 3. Now can I use a shortcut? Let us use a shortcut. So the shortcut was what? Here cos inverse, cos is what? Base by hypotenuse. So this base is 1 and hypotenuse is 3. So if I have to transform into sin inverse, so sin inverse is what? Perpendicular by hypotenuse. So my hypotenuse is 3. So denominator will be 3. Now perpendicular will be what? It will be root over of 3 square minus 1. So that's coming out to be sin inverse square root of 8 by 3. That is equal to sin inverse 2 root 2 by 3. So that is a way to use the shortcut and find the answer. I hope you are very aware of this shortcut, but please don't use it. It's only will be used for competitive exams, or you want to check your answers whether it's correct or not, or else you cannot write that that shortcut in your board exams, or else the whole problem will be cancelled. You will not get your marks. So now here we have another question that is proof tan inverse root x is equal to half of cos inverse 1 minus x divided by 1 plus x. So when I look at the problem, here it's a different kind of problem. Previously we had all problems in where the left hand side was creating the problems, but here the right hand side is quite bigger and it's now creating a problem. So always start with the bigger ones, because it's easy to simplify the bigger ones than to simplify this square root, and it will create so many problems. So let us start with this one. So what we have right hand side, the right hand side is half of cos inverse 1 minus x divided by 1 plus x, right? Now what I will do is, I see tan inverse in here. So let us try to get tan inverse in here. So what I will do is, let cos inverse 1 minus x by 1 plus x is equal to y. So it becomes 1 minus x by 1 plus x is equal to cos y. Now since we have cos, I need sine to get tan. So what I have to do is, I'll write sine y is equal to root over of 1 minus cos square y is equal to root over of 1 minus x by 1 plus x whole square, because cos y is what, this one. So what I will do, so root over of 1 plus x whole square minus 1 minus x whole square divided by 1 plus x whole square. So 1 plus x whole square minus a 1 minus x whole square, that gives us our 4x divided by, and this one gives us 1 plus x. And obviously there will be the square root in there. So we have a big square root in here. So what we get is, now if I have to write this one up, so what we get is, this one is equal to, let me write in here. So sine y is equal to 2 root x divided by 1 plus x. Now we have to find tan y. So cos y is this one, sine y is that one. So tan y is equal to what? Tan y is equal to sine y by cos y. So we have 2 root x by 1 plus x divided by 1 minus x divided by 1 plus x. So this gets cancelled. So we have 2 root x divided by 1 minus x. So this is my tan y. So therefore y is equal to 2 root x divided by 1 minus x. So this is my y. Now the problem is still not complete. Okay, we have made a mistake. Tan y is this one. So y is equal to tan inverse of this thing. There is a mistake, sorry. Please don't. Yeah, this is what we have. So now we'll move on to the problem. What we have is half of this thing. So what we have is half of tan inverse 2 root x divided by 1 minus x. So I can write this one as what? Half of tan inverse, when I look at this problem, 2 root x, I can write this one as root x plus root x divided by 1 minus x. X we got as what? Root x whole square. So it is actually what? Root x into root x. So this basically signifies that it is the formula of tan inverse. Half of this is the formula of nothing but 2 tan inverse root x. So this 2 will get cancelled. So we have tan inverse root x, and that is what is in our left hand side, and that's proved. Okay. So thank you everyone. That's all for today, and see you again in our next class. And if you have any doubts, any queries, please do email us. And until tomorrow, please start revising your lessons. So that's it for this chapter, inverse trigonometric function. So thank you.